Welcome to the Strive Seek Find podcast with me, Tom Heaton. I hope that my last episode was able to give you a compelling justification to dedicate time to continual learning, as I aim to persuade you this really is a key that can unlock a huge number of doors for you. With this in mind, I wanted to use this episode to begin the process of exploring learning theory in greater depth in order to start understanding how learning may be better done. I will start here by spending a bit more time defining what I actually mean by the term learning. I then aim to provide a general overview of the key models of what is happening in our brains when we learn. This should hopefully provide a framework for future discussions as we begin to explore the different components in more detail. So what is learning? I think it is always useful to be clear in our meaning of key terms, and having an effective definition is a vital starting point. There are many ways that people might use the term learning, all with slight differences. Some may be purely thinking about the retention of specific facts, something more akin to memorization. Some may be thinking of specific actions that people can gain proficiency with, such as learning to ride a bike. However, the general concept of learning seems bigger than these focal cases. Indeed, learning is something that really is a particularly special feature of us as humans, our niche, if you will. As such, my favourite definition centres around what the main goal of our learning actually is: problem solving. This seems to be the specialisation of our brains and where we excel. As such, I like the definition of learning being an increased ability to solve problems. Its brevity is a strength, but I also recognise that some people may prefer a bit more detail. As such, I also very much like the definition from the authors of Make It Stick, an excellent book, describing learning as acquiring knowledge and skills so that they are easily accessible for future problem solving and opportunities. This brings some clarity about how it is the embodiment of skills and knowledge through which learning occurs. However, the scale of these can vary widely, with skills ranging from very specific tasks through to high-level problem-solving abilities. It is also interesting to note here the closeness of such definitions with how we might begin to define intelligence. This link is something that we will come across again. For now, I think we should move steadily on to better articulate what this looks like in terms of a general model. To start with, we seem to be very clear in our current understanding that learning is a neurological phenomenon. As such, learning is a feature of the central nervous system, most particularly the brain, and not something more ethereal. It is increasingly being understood how it is the architecture of the different nerve cells throughout our brain where learning, or the results of learning, is stored, for want of a better word. These neurons are the building blocks of our learning, but it is the way that they are connected with each other that manifests as a result in knowledge and skills. As such, there is not a single neuron or chemical neurotransmitter that relates to learning, but entire webs of them. There are definitely areas of specialisation in the brain, but learning seems to be spread widely across it rather than in specific pockets. I think of it as huge webs of connected cells that are spread across the brain that each carry tiny amounts of information. When these are summated, they express the outcomes of different complexity. The actual process of learning is about strengthening these pathways by strengthening the component neural connections. The analogy to a muscle can be useful here, although very incomplete, as it demonstrates how there is an increase in function with repeated use. Learning is therefore directly modifying your brain to make it better at whatever the goal is. This neurobiological basis fits in well with some of the learning theories that have been developed through time. The key ones that I think are important to know from the start are constructivism and the related social constructivism, and cognitivism. The constructivist description is the one that I find most valuable and is essentially just a description of what the previous neurobiological understandings tell us. That is, that knowledge is a construction of the brain. It builds this knowledge by creating it out of the current building blocks that it already has. As can be appreciated from this means that learning has been a continual process ever since you were born. You have been constantly adding knowledge using the information that you already had, starting from when you were still just trying to understand what the world even was. This continues to build as you develop words, then full-on language, increasingly complex concepts and numerous discrete pieces of knowledge that fit together to help you understand. We build our knowledge rather than downloading it, as a computer model might suggest to us. The cognitivist approach is slightly different but still very relevant to learning. I think of it as being a better analysis of the small processes that go on in learning, whilst constructivism is a general description of the big picture. That is because there are lots of smaller cognitive processes that we're constantly utilising, and that these are being increasingly better understood. These are essential features of our brain's processing system and can, and perhaps should, be exploited when we are learning. A simple example of this is our innate preferential memory for visual spatial material. Many memory champions, as well as less intense learners, maximise their retention and recall by converting information into something highly visual spatial in nature. Something that is very visually striking is very memorable, and this can be tied to something that they want to remember. Similarly, the memory palace technique creates an imaginary place to store such visual information, which can be retrieved by picturing walking around it. These are some specific examples that we will look into in more detail in future discussions. There are also many other similar features about our brains that we can utilise to make us better learners, but we need to understand them first. What is interesting about them is that some of them are not very obvious to us as we are trying to learn. Indeed, we may be using cognitive approaches that we find comfortable rather than because of their effectiveness. Indeed, as we shall explore, we can actually be completely deceived about the effectiveness of learning because of how they subjectively feel to us. So, to summarise the key parts, learning is about improving our ability to solve problems, generally through the acquisition of skills and knowledge. This is stored within the structure of our brain by virtue of the connections and pathways of the component nerve cells. These connections are constructed over time, building into one massive web of connected information, constantly building on previous knowledge. The actual processes of our brain have specific features, you might call them quirks, that govern the way such learning happens and the way that it gets implemented. An appreciation of all these features allows us to optimise how we learn. The specific ways in which this can be done will be the focus of future discussions, drilling down into the details of some of these models and the evidence behind them. Thank you for listening. To keep up to date and to follow my writings, subscribe to me on Substack, which is striveseekfind.substack.com, or follow me on X at @2striveseekfind.